Hello and welcome again as we consider yet another multiple choice question for IB chemistry. Which change is exothermic? To solve this question, there are two bits of information that you need to have at your disposal. First of all, you need to know that an exothermic process, as opposed to an endothermic process, releases energy, whereas the endothermic process takes in energy. In an exothermic process, the reactants start off with this amount of energy, go over an activation energy barrier, end up as products, and you have this difference in energy. This bit of energy here, this is what is given out to the surroundings. So the system loses energy to the surroundings in an exothermic process. Energy is released in an exothermic process, and we say that the enthalpy change is a negative delta H because the system has lost to the surroundings. So the negative sign referring to the loss from the system to the surroundings. And we should also consider what an endothermic process looks like. In the endothermic process, the reactants having this amount of energy will transition over a barrier and become products. The products would have to have an elevated amount of energy. Where is that energy coming from? That energy has to come from the surroundings into the system. The system gains energy from the surroundings. So we have a positive delta H. So now that we know an exothermic process releases energy to the surroundings, that doesn't help us to solve this question. What we also need to know is the bond making, like this, releases energy, but bond breaking requires energy. So it follows that if bond making releases energy and bond breaking requires energy and exothermic processes release energy, then an exothermic process would be one that involves bond making. And once you have that connection made, then you can look at the four answers to see which scenario will symbolize bond making or the building up of a system, and which other three would symbolize the breaking up of a system. Because if one of these is exothermic, the other three will be endothermic. The one that's exothermic will have some kind of building up or bond making, which is exothermic, and the other three would have bond breaking, which is endothermic and requires energy. So let's take a look at the four answers. Half Cl2 becoming a single chlorine atom. What this symbolizes is two chlorine atoms that make up the Cl2 molecule breaking apart. Bond breaking requires energy. If it requires energy from the surroundings, then it's going to be endothermic. Potassium as a gas. So this is a potassium atom in the gas state. And what it's doing, it's losing an electron to form a potassium ion. That's going to require energy to lose that electron from the outside of the atom. So that breaking apart of the system is going to require energy from the surroundings. Bond breaking requires energy. So it's not going to be B. C. KCl, an ionic solid, potassium chloride, that breaks apart and forms two ions in the gas state. Potassium ion as a gas, chlorine ion as a gas. That's going to involve a lot of breaking apart. That too, bond breaking, it's going to require energy from the surroundings. It's going to be endothermic. So by a process of elimination, we are pretty confident that the answer is D. Let's have a look at why. Chlorine atom in the gas state gains an electron. It's building up now. It's not breaking apart like here. It's 2, 8, 7. Needing that one valence electron and then getting it to become 2, 8, 8, which is the chloride ion here. That is very much a building up process, a bond making process. And bond making is exothermic. It releases energy to the surroundings. So the answer to this question is D.